Welcome to section 9.1, review of operations and composition. And this is talking about for functions. Alright, so let's go ahead and review the operations on functions. So, operations on functions. If we have f plus g of x, what does this mean? We're going to take f of x and then add to it g of x. And then f times g of x is just going to be f of x, and you're going to multiply it to g of x. Now let's move on to the other ones on the side. So f minus g of x is going to be f of x minus g of x. And then we have f divided by g of x. That's just going to be f of x divided by g of x. And we have to be careful here. Because g of x is in the denominator, we need that g of x cannot equal 0. Because we cannot have zeros in the denominator of a fraction. And lastly, the one you have to be kind of careful about, it may look like it's multiplication, but it's not. Notice that open dot, once again, that is called the composition. What we're doing here is the first function, and you're taking the second function and inputting it inside the first function. Okay, so that's composition. It is different than multiplication. So let's take a look at the example. Given the functions, we're given f, g, h, and k. So let's say we have f, g, h, and k. We're asked to find the following. Answer over complex numbers as needed. What does that mean? That means if we see an imaginary number, so let's say a negative under a radical, we can continue on and answer with a complex number form. We don't need to say not a real number. So if we weren't told to answer over complex number forms, usually we'd just answer not a real number. But if you do see that you can answer over complex numbers, then you go ahead and answer in a plus bi form. Alright, so the first one, we have f of negative 1. So what that's saying is, your new input, instead of x, is negative 1, so you're going to replace x with negative 1. So then f of negative 1 is going to equal negative, and we're told to replace x with negative 1, so negative 1. Careful, there's a lot of negatives going on. Negative 1 squared is going to be positive 1, but we still had that other negative 1 out front, so that'll be negative 1. Next one we have is g of 1/4. So g of a fourth, wherever we see x, we're going to replace it with a fourth. So in g, x is right there next to the 2. So this will be 2 times that fourth plus 9. So when we see that, we can go ahead and simplify. That'll be a 2. And then we have 1/2 plus 9, which is just going to be 9 1/2. I don't really care too much if you answer as a mixed number or as an improper fraction or a decimal. Unless otherwise stated, as long as it's simplified, I'm good with that. Alright, so h of 1. Well, our function h is this one with the radical here. And where's x? X is underneath the radical, and there's a negative by it, so we have to be careful with that. That's the square root of negative my input plus 2. So we're inputting 1. Let's go ahead and input 1. And we get the square root of negative 1 plus 2, which is the square root of 1. And that's pretty straightforward. What is 1, or what number times itself gives me 1? That's just 1. Next we have k of 1/2. And what is the k function? K is 5 over x plus 4, and that's my x value there. So we're going to replace that with 1/2. So k of 1/2 is going to equal 5 over, and we're replacing the x with 1/2 minus 4. Interesting. So we have 5 over, let's see, 1/2 minus 4. I have to create the same denominator here. So multiply by 2 and 2, so that's going to be 1 minus 8 over 2. Which will be 5 over negative 7 over 2. And that's just going to be 5 divided by negative 7 over 2, which when I simplify it is going to be, when I'm running out of some space here, 5 times 2 over 7, once again negative. Let's use my little arrow here to indicate I'm moving that way. And that's just going to be negative 10 over 7. And we're done there. Okay, let's move on to h of 5. So once again, we're using this radical one here. So h of 5 is going to be Well, we're just replacing that x there with 5, so that'll be negative 5 plus 2, square root of negative 3. Ooh, can we have a negative under a radical? Well, that depends. If we're solving over complex numbers, we would keep solving. But if we're solving not over complex numbers, we would just say not a real number. Which one are we working with? Well, we were told that we could solve over complex numbers as needed. So because of that, I'm going to keep solving, or simplifying, excuse me, and answer in complex number form. So to simplify this, we have that negative under the radical. And remember, that is I, so this is going to be I root 3. So in complex number form, there is no real part, so it's just going to be 0 plus root 3i. Once again, the I is at the end, so I use that little tail by my radical, just so you know that the I is not underneath the radical. And then we have k of 4. So k, once again, is that fractional function. So k of 4 is going to equal, and we have 5 over my x value. I'm replacing with 4 minus 4. So that's going to equal 5 over 4 minus 4 is 0. Ooh. So we have two options. We have a number over 0 or 0 over a number, and they have different answers. Well, a number over 0, that spells no. N-O, no can do, so this is undefined. If we had 0 over a number, that would spell on, so we can go on to 0. Which case do I have? I have a number over 0, which spells out no. No can do. So what would my answer be? It's going to be undefined. Anything divided by 0, undefined. Okay, so the last two ones were a little tricky there, but keep an eye out for those. Alright, so now we have something that we're looking at is the domain of addition, subtraction, multiplication, and division of two functions. So on page 589 of your textbook, if you want to go ahead and read that separately, the domains are as followed. So if we have the functions f and g, what do we know? Well, the domains of f plus g, f minus g, and f times g are true, or include all real numbers. So that big capital bar R means all real numbers in the intersection, so this means intersection, of the domains of f and g. And don't worry about that too much. We'll go into the examples of it in a sec. So just write that down, and then definitely read over it after we do the examples. Usually that helps clarify it more. Now, the next one. So we only covered addition, subtraction, and multiplication. We still have other ones. So the domains of f divided by g includes the real numbers. So the real numbers in the intersection of the domains of f and g, but we have something else we have to watch out for. What do you think? We're working with a fraction. What else do we need to be careful about? Except when g, for g of x equal to 0. Okay, so we cannot have g of x equal to 0, so we have to take that number out, or the numbers out that make that happen. Let's go ahead, and now we're going to work with the composition. Okay. So given f of x is 2x minus 4 and g of x is the square root of 3x minus 1, find each of the following and give their domain. Alright, so let's see. F plus g of x, that's going to be f of x plus g of x. So f of x is 2x minus 4 plus, and g of x is the square root of 3x minus 1. So that, we really can't add or subtract anything here, so that is just what it's going to be. Okay, so then to find their domains, we first need to find each domain separately and then find the intersection of them. So the domain for f of x, well, if you look at f of x, it's just a linear. It's a linear equation. How do I know that? Well, just because we have x to the first power. So since it's linear, the answer is all real numbers. We don't have any restrictions. So that'll be negative infinity to positive infinity. Now the domain of g of x. We have to be careful here. There's a radical. That means I know that the items inside need to be greater than or equal to 0. We're not solving over complex numbers, so we can't allow for any negatives in there. So we need 3x minus 1 to be greater than or equal to 0. So let's go ahead and solve for x to find out what values make that true. Okay, so then we get 3x greater than or equal to 1, divided by 3, and we get x is greater than or equal to a third. So this means that x needs to be greater than or equal to a third. So we can include a third, but it needs to be greater than. So now, the domain for my function f plus g of x is supposed to be the intersection of this domain and this domain. So let's go ahead and write that out. Let's find the intersection. Okay, so we have a third and then just infinity for the other. So for negative infinity to positive infinity, that covers the whole shebang. But for the domain of g of x, because we had that radical, we can't allow all numbers. So we can allow a third and anything bigger. And remember, we need the intersection of these to be the domain of f plus g of x. So the intersection is going to be all of these numbers. So the domain of f plus g of x is going to be 1/3 to positive infinity. So once again, you find their domains separately, graph them together, and find their intersection, and then that would give you the domain. So let's go ahead and take a look at the other one. So first off, let's find f minus g of x. So that's going to end up equaling g of x minus f of x. So g of x is the square root of 3x minus 1 minus 2x minus 4. Not too exciting. Once again, nothing really adding or subtracting for these. Mainly, we're just working on these for the domain and range. Okay, so let's go ahead once again. What is the domain of f of x? We already found that earlier, so negative infinity to positive infinity. And the domain of g of x, we also already found that earlier. 1/3 and infinity. And basically, because nothing else really much is happening, it's still just going to be at 1/3, and we just intersect them. And then once again, where is their intersection? It's here. And so then the domain, and once again, watch the notation on this. The domain of, we have g minus f of x is going to be the 1/3 to positive infinity. So how we do it doesn't change if it's multiplication, or addition or subtraction. So let's go ahead and see what we have next. We have multiplication up next. So we want f times g of x. So f times g of x, that's going to end up equaling f of x times g of x, which is going to be, let's see, what is f? F is 2x minus 4, and g of x is square root of 3x minus 1. Okay, so multiplying that out, it's a little weird, but we distribute that to that and that to that. It'll be 2x root 3x minus 1 minus 4 root 3x minus 1. Okay, so that's the multiplication of them. And then the domain is basically going to be the exact same thing as we had before. We're not doing too much on actually finding those things. So 1/3, and then the domain for all real numbers for f of x was all of these guys. And the domain we found earlier for g of x was 1/3 and above. And then we just find the intersection. So the domain of f of g of x is 1/3 to infinity. Alright, one more to go. F divided by g of x. Okay, so that's going to be f of x divided by g of x, which is going to equal, well, f of x is 2x minus 4, and g of x is the root of 3x minus 1. So, we have to be careful now, though. Remember, the only time the domain finding changes is when we talk about division. And what changes with division? We can include all values except for when g of x equals 0. So, g of x equals 0 when what? Well, I don't know. I need to figure that out. So when does g of x equal 0? We're going to check that. And then we're going to take that number out of our interval. So root 3x minus 1, when does that equal 0? So square both sides. And then we get 3x minus 1 equals 0. And solving that, x equals 1/3. So the value we cannot allow is 1/3. Which means the new domain for g of x, instead of being including 1/3 to infinity, we can no longer include 1/3. Okay, so we had that new domain because it's in the denominator. So let's go ahead and graph that. Here's the 1/3. So this is all real numbers from the f of x. And then the g of x, this time we're not including the 1/3, and we're going forward. But once again, we still take the intersection. So that's all of those values there. So what is the domain of my two functions now? It is going to be the domain of f divided by g of x is going to be 1/3 to infinity, not including 1/3. You've got to be careful with the division. And we're not going to be finding the domain of composition. Okay, so nothing with the domain of this, just with the other functions. So now we're moving on to the difference quotient. Now what is the difference quotient? Well, it basically comes from finding slope, but instead of just finding the slope of straight lines, or basically what we would say is lines, it's finding the slopes of other curves. You'll go into more detail with that if you go into some of the higher math courses, but for now, we're just going to go over the basic look of the difference quotient. Alright, so you probably have seen it at some point, but the difference quotient is basically going to be f of x plus h divided by h, and we're going to take the subtraction of f of x. So it's f of x plus h minus f of x all over h. Alright, and that is if you're working with the function f of x. So find the difference quotient given that f of x is equal to 2x squared minus 1. And this is the last example in this section. Okay, so first off, what do we need to find the difference quotient? Well, we need f of x, and then we need f of x plus h. And you might say we need h, but h is just a variable. So the only function items we need are f when you input x plus h, and then just f of x, which we already have that one. So let's find f of x plus h. Now, some students like to do this inside the problem. I'm going to do it outside for now, even though I myself usually do it inside the problem. It's just because sometimes there's a lot going on. So what is f of x plus h? Well, what we're doing is we're replacing x with x plus h. So wherever we see x in the function, we'll replace that with x plus h. So that's going to equal 2 times, and we're replacing x with what? X plus h. Kind of a weird input, but that's what we're replacing x with. So x is gone, replacing it with x plus h. And then we're subtracting that 1 from there. So let's simplify this out. That's going to be 2 times x plus h times x plus h. Once again, that square just means the binomials times each shelf. So that'll be 2 times x squared plus 2xh plus h squared minus 1. Let's distribute in that 2. It'll be 2x squared plus 4xh plus 2h squared minus 1. Okay, so that is f of x plus h. What do we do with it? We're going to input this into the difference quotient. So in the difference quotient, we have f of x plus h, and we're going to subtract from it f of x, and then divide it all by h. So f of x plus h is equal to this right there. Then f of x is equal to that. And h is just h. So let's put in parentheses. We have 2x squared plus 4hx plus 2h squared minus 1, and then we're subtracting from it f of x, which is 2x squared minus 1, all over h, which is once again not a function. H is not a function, it's just a variable. So let's color code that. This was f of x plus h, and this was f of x. Now let's go ahead and distribute that negative. Once again, be very careful with the parentheses. Make sure to use them. So just dropping the parentheses for that, because we don't have any negatives. And then we get negative 2x squared plus 1. Now at this point, what usually should happen is anything that does not have an h in it should cancel out. So let's see, so the 2x squared cancels with that, and the 1 cancels with that. And the only items left are the ones with h on the top. So that's a good way to check that you did it right. So this is going to be 4xh plus 2h squared over h. Now let's see if we can simplify this. Well, in the top, they all have a 2 and an h. So let's factor that out, and then we're left with 2x plus h divided by h. Ooh, and then those h's cancel. And I'm left with, let's go ahead and jet out to the side with the arrow, we're left with 2x plus h. 2 times 2x plus h. Alright, and that is that for the difference quotient. So definitely a lot with functions. Be careful. Check your notation, use parentheses if you need to, and watch the positive and negative signs. Alright, that is it for this section. If you have any questions, once again, please stop by my office hour or email me and we'll set up a time to meet.